Okay, so there might have been an ever so slight possibility that I forgot to plug in my mixer because I switched up my cables around. And the point is, hello everyone and welcome into yet another live stream. And for a second I thought my channel was broken, but apparently no. This was a piece of music. Ah, that's loud. But apparently no. No one said hello. Hello, come on. No one really. Oh, I'm gonna wait. I'm too comfortable starting a main channel stream with no one here. Crinkle, hi the Crinkle, hi, well, perfect timing, hi there, now we can start the live stream. So, today, hello everyone and welcome into another live stream. And today we'll do a research live stream, just like yesterday, except there'll be a certain key difference, and what will be that key difference? I'm so glad you asked. It's going to be... There we go. This is our thing. Hi there, Rob. Hi, this is Robot. Finally got the chance to watch your streams again. It's been ages. It really has been. Really. Oh my goodness. Wait, what was the last live stream? I think it was the forest one, right? The 400 one or 350? I don't... Yeah, I think it was the... Oh, that was ages ago. But today it's gonna be a main channel stream, which means it's going to be a research live stream. And today we're gonna be researching... You heard me. And today we will be researching something fun. Yesterday we were doing macroeconomics because... I don't know. I don't know why. I thought... Well, to be fair, I started the live stream knowing damn well that wasn't gonna be a good idea, and it turned out decently okay. But today we'll do something different. They will go into the engineering tab, but a certain kind, because there was a certain textbook which I found a while back when I think it was on the Transistors stream if I'm not mistaken. We found a textbook about electricity and material science, and it was the most amazing textbook I have seen on the site so far, and I would really like to find it again. I don't know which one it's gonna be. It's gonna be material something. Material application. No, maybe it was chemistry. No, because only the first chapter was about well, I remember first two chapters being about chemistry. Introduction to nanoelectronics, kind of, actually. I could just open up the live stream and see what was the book. Which website is this? This is LibraText. Right here you can see LibraText and move the day down. There, it's LibraText. It's my beloved website, which I absolutely adore because it provides free and open textbooks about everything you'd ever need, and I would recommend. It's great. Hold on, let me check the Transistor stream. I think it was the Transistor stream. Okay, so it was the engineering one. Material science. It was material science. I have good memory. Material science. Could it be this one? Let's see. What is it? TLP library? Let's start the first one. I didn't... the first one yet, so, you know, I'll get confused by the second one. Too many... Not quite, though it does look interesting. Wow, 35 chapters, cheating. So, no, this is not the one. We're looking for... Let's see. Material science for electrical engineering. Makes sense. Actually, title is... It's very descriptive. Material science for electrical engineering, yes. Now, gonna be fun. Is this the one? Solids, electrical properties, phases, magnetism, thermal. Wait, what? I think so. No, it's not. Ah, oh, dark nabbit. I may be wrong, but I do believe that the third chapter had sub-chapters about MOSFET and different semiconductors. So I was correct. This is the one again. Okay, I'm gonna paste it into the description because I know that a lot of people like having textbooks as an option. There we go. It's in the description. 7 minutes into the stream and we're already into material science. Yeah, that's what we're doing today. That's the topic of the stream. That's good, right? Starting the stream, really solid. I've been trying to find a way to study the entire elementary maths during my spare time math exam, and I haven't been able to find any good ways. LibreText! LibreText! I hate to be, you know, a sellout, but I would actually love to be a sellout for LibreText. If LibreText would like to sponsor me, I don't know actually why would they sponsor me. The organization, they don't really make money off it. But if you want my endorsement, this is a great site. I love that. It's LibreText. Obviously I love it. Alright. Everyone ready? Oh wait, I just realized we're missing the thing. We're missing the textbook, not notebook, not textbook. There is no text. There will be text once I fill it in. The place where we will note, which means textbook. So all right. Give me a second. Technical difficulties, okay? Very slight technical difficulties, which I will fix now. There we go. There we go. That's our notebook. Sick. It's in bright mode, which isn't ideal, but we'll be fine. Okay. Anything anyone like to say before we dig into this absolute delicious, delectable meal of a textbook? This background music sounds like Undertale. Did Soda KC make the music? Yeah, it's Soda KC Music. YouTube, https://youtube.com/add Soda KC Music, where you can get more of this music, like this, which is called Rainy Day. Or that's https://youtube.com/add Soda KC Music, where you can go listen to more music, but by Soda KC Music. youtube.com/Soda KC Music. We can music Soda KC by made. Anyway, I'm hoping you can also hear me better. I tried to fix the audio last stream, and so usually I was getting cut off all the time, and I think this time it should be at least a bit better. Although I don't know. If you think that I'm getting cut off, and if you think I should still fix the audio a bit more, just let me know. Anyhow, let's dig in. Pseudoscience. Why are we studying pseudoscience? Fringe alternative science. Multiple defects. Why are we studying pseudoscience? Is it like, this is not pseudoscience? Is that the start? Well-documented instances in which the correction process referred to above was delayed until the initial correct interpretation became multi-purpose. I like that, you know, there are several well-documented instances about pseudoscience, which I think is just comical sentence. I love this already. Okay, but okay, this is great. This is just about science, and it's neat. Oh, there are sub chapters. Okay, let's begin into the first sub chapter of the. No wait, let's begin into the first sub chapter of the second sub chapter of the first chapter. Why they're saying it's pseudoscience? They are not saying it's pseudoscience. They are saying that, you know, you have pseudoscience, and if you examine electricity with pseudoscience, then you'll mess up. And so it's important to science. Unless I misread that. Properties of matter. We will skip over a lot. Hi, the Feeble. We will skip over a lot for the main reason being that it's just a massive textbook. And also it starts with the basics. The ratio of two extensive properties is also always an intensive property. This is... I call it complex units. I guess it's good to learn vocabulary. because since, you know, my entire shtick is making science videos, I don't want to spread misinformation for no reason. Alright. Nonsense, although it might be quite true in particular instances. The properties of this kind are called extensive properties of matter. Oh, I see. So extensive is just... okay, makes sense. Suppose we take further measurements and find that the same quantity of water whose mass is 2 kilograms also occupies a volume of 2 liters. Measure two extensive properties, mass and volume, of the same sample matter. This allows us to define new quantity portions, mass per volume, which is density. Okay, so extensive properties. The music is so loud. Let me just bring it down. There we go. So, hi there, by the way, and welcome to the only YouTuber that live streams, making their animations in Blender and live streams the textbooks. You could have then, no, we could just end it there. Welcome to the only YouTuber. Anyhow, so when it comes to extensive properties, would be like case-on-case basis, and then intensive properties are basically like more generals. And then you have the ratio of two extensive properties, which is an intensive property, because even though the mass of water may vary depending on the amount of water, and the volume of water may vary depending on the amount of water, the ratio will not vary depending on the amount of water. Makes sense. Hello, hopefully all of these are doing well. Well, I'm doing well. How are you doing, Ninja? Hi, how are you doing? How's your day going? Intensive properties are extremely important because every possible kind of matter possesses a unique set of intensive properties that distinguishes it from other kinds of matter. Makes sense. Different things have different density, have different... Hi there, Happy, hi. Different densities, different... colors, I guess. I don't know. I can't think of any other property. What other properties are there that are like intensive? Hold on, I can figure this out. It's fine. I can do it. Calories would be an intensive property. I don't mean hey Tiddy. Feeble, you only have one thing on your mind, and it's awful. Anyhow, okay. I think calories would be a decent example. Pretty certain. I don't know. Some intensive properties can be determined by small observations: color, melting point, density, solubility, acidic or alkaline nature, and density are common examples. Wait, that's density twice. Okay, even more fundamental but less directly observable is chemical composition. Okay, makes sense. The more intensive properties we know, the more precisely we can characterize sample of matter. So basically you have extensive properties, so... oh, you have intensive properties, so apples, and then you have extensive properties, so this apple. Okay. Properties can be extremely important because every possible kind of matter possesses a unique set of intensive properties that distinguish from the working properties set to characterize matter. Okay. So intensive properties. Apples. And extensive, right? Extensive properties. This up, and then intensive properties to characterize matter. Take. Finger learning material science. Yes. I think it's chemistry. It is chemistry. Yes, it's chemistry. Well, chemistry, material science. I suppose they're both similar. Oh, wow. See what I told you? This is like the initial introduction chapter. In the last textbook about macroeconomics, the introduction chapters were just a solid block of text. Right here, on the first one, you already have graphs, you already have examples. Oh wait, are we gonna do examples? Should we? No, let's do it. Which of the following extensive... Wait, what happens if I... Okay, oh, I click on it already. Okay, so this is an extensive property. Nah! This is... intensive property. Yeah! This is number of calories of energy derived from eating banana. Can anyone tell me what this property is? C. Everyone, now it's welcome back to school. What's this property? Is it extensive or intensive? I want to see. I'm gonna check. You know what? Like, yeah, let's check if you're paying attention. Let's see. Let's see if you're paying attention to live stream. Come on, is this extensive or an intensive property? To be honest, I don't know. I kind of guess it, but maybe extensive. Axis, I don't know. It is C. Come on, y'all. No one. No one. Number of calories of energy derived from the banana. Explain to us. I'm disappointed. I'm so disappointed. It is the intensive. Wait, is it a banana or the banana? Wait, it is intensive, right? Depends on the banana. Extensive. Ah, yay, Robert! Congrats, you'll win something. We'll figure out the rules later on. Yes, we get the idea. One is way of organizing the understanding matter is to think of hierarchy that extends down from the most general to the most complex to the simplest and most fundamental. The orange colored boxes represent the central realm of chemistry, which deals ultimately with specific chemical substances, but as a practical matter, chemical science extends both above and below this region. Okay. Makes sense. The neutrons aren't part of chemistry? That's news to me, actually. Is this just alchemy? Precisely. We're learning alchemy today. I'm studying this stuff, let's go. See, you can use it in real life. Well, you can't, we're still learning about it in theory, but just trust the government, man. Okay. Makes sense. I call it abstraction, and I've made like 7 videos about this. Alternatively, when we are thinking about specific examples of matter, it may be more useful to recast our classification in 2 dimensions. Heterogeneous matter, homogeneous matter, mixture, pure substance mixture, and examples. Cool. Heterogeneous equal and pure, yes. We have descriptions right here too. So like homogeneous is uniform and heterogeneous so more than one set of its properties. Or just, you know, homo as like single, hetero as like multiple. Oh damn. we can remember like this: homo, single, hetero, multiple. That's what these words mean. And so this is a single, uniform, and then hetero, which is more than one. That's just a freaking synonym of multiple. I'm sweating trying to understand this. I'm lost. I've never been trying to understand something so hard that I actually start to sweat. But you know what? I can sympathize. It's fine. We'll get there. We'll get there eventually. So yeah, we have heterogeneous, which means multiple things, and then homogeneous, which means a single thing. So a single mixture, for example, would be salt water, because you have salt and water mixed together, but they make up just a single substance. And then you have pure, which is sulfur, for example, because sulfur is only made of sulfur. There you won't find no coal, no carbon, no oxygen, no hydrogen. It's sulfur and it will stay there. Don't look at salt, that's not important. Don't ask about sodium and chlorine and about how it's different. That's not important, okay? It's not important because it's a molecule. The point is, heterogeneous is like multiple things. So ice floating in water is technically just water, right? But in practice, you have these two separate things, ice and water. And mixture that, you know, you have like concrete, which is multiple different powders mixed together. It would be actually easy to understand as like how to remember is imagine you're single, you're a mess. Couldn't be me, surely. Nah, don't worry. I mean, you know, there's nothing wrong with being single. I mean, I'm not. I sleep with so many men. The partners, people, humans. The women. I mean, yeah, I'm getting. Was that table? That's what I was doing. Yeah, right. So table of 4. That's what we're doing, and so there we have heterogeneous. I love it when words have like EOU in it. It's always so lovely and fun to remember. Homogeneous. Genius. That's precisely how you're supposed to pronounce that. Pure substance. Nah, I just got to McDonald's. Ah, damn. I feel like an American. I've been wanting McDonald's. You can get an ad block. You don't have to, though. No, you don't have to get an ad block. Just, you know, we're having fun. So, heterogeneous is multiple things. Miss a mix. So, this week over here we have. I know if concrete is like. I guess concrete is a decent example. I could make. No, don't worry, I don't get paid anyway. Then we have. Well, I guess salt water is like a better. I'm just trying to think of a different example to concrete, like something which. Nah, it's good enough. I'm thinking. Happy, you make it to a charity segue. Oh, so I'm so glad you just mentioned that. Speaking of charity, link in the description on the screen right now. https://makeitupis// and go to my charity and get a slice of pie for yourself. Once again, that https://makeitupis// and go to my charity DBS Alliance. Help people with depression and bipolar disorder and get a slice of pie for yourself. Wow, what a smooth segue. So you know what, Robert? I like you. And pure substance. This is such a... I mean, this is just like a single substance in different forms, right? Yeah. And then I like sulfur in this, for this example. Borderline boxes that mixtures and pure substances can fall in either homogeneous or heterogeneous. Yeah, you... So, yeah, this. Oh, whoops, not what I meant. Anyhow, it's a matter of phases. Oh. Homo, same, hetero, different. I guess those are... Okay, I guess single and multiple, that was just me being delusional, wrong, and incorrect. Oh, wow, first time for everything, I guess, am I right? Up top, everyone! Okay. Cannot being uniform and continuous, whereas heterogeneous matter implies non-uniformity and discontinuity. To take this further, we first need to define uniformity in a more precise way, and this takes us to the concept of phases. This is interesting because this is already way out of my depth. I've never heard of phases in this context, so Interesting. A phase is a region of matter that possesses uniform intensive properties throughout its volume. A volume of water, or a chunk of ice, a grain of sand, a piece of copper. Oh, I see. That makes a lot of sense, and that's actually a lovely way to define it. Boy, oh boy, do I like scientists. As in platonic sense, you know. Kind of like... phase. Region of matter that possesses... So we can think of it as like unit of a substance. Right? Christians take care of this guy. He's teaching us magic. Witchcraft. Just for your information, Happy, he's got a charity website called Such a Pie. Wait, do I? I've never heard of that before. Could you comment some more on this weird sounding website? Was it Slice of Pie? Like a... What? Sounds bizarre. I would love to learn more about the Slice of Pie charity. Okay, so phase is like a single unit of a substance that possesses uniform intensive throughout its volume, like a single unit of substance. If only we had unit of substance. Happy you just deleted the message. That's 10 minutes. This uniform intensive properties, that's important. That's pretty important. So let's do Control I. Alrighty then. I have the size of pie charity. I wonder how it relates to the economy. It's just a bit big, like a, you know, money laundering scheme. I mean, tax evasion. I mean, charity. So, phase boundaries. Each phase in a multi-phase system is separated from its neighbors by a phase boundary, a thin region in which the intensive properties change discontinuously. Makes sense. Why you can easily see ice blending water, although both water and the ice are transparent. The answer is that light crosses the phase boundary, its direction of travel, like the burned portion. Okay, so that's another useful term. Remember, phase boundary. You know what? So far, this is gonna be one of the most satisfying things to learn. Out of all of the different child checkup research live streams, this is gonna be one of the most satisfying ones. I love this textbook so much. Multi-phase system. So like a separation. Discontinuous separation. There is no way anyone is spelling discontinuous on the first try. I refuse to believe it, and I will live in denial. Between different phases. Okay. Travel material. The second phase is broken into tiny particles, and light rays usually bounce off the surface, and many particles before they emerge from medium and under the eye. Phenomenon scattering gives multiple systems cloudy appearance, rendering them translucent and transparent. Two very common examples are ordinary fog, in which water drops are suspended in air, and milk, which consists of butterfat globule suspended in aqueous solution. Discontinuous. Second try good enough. Precisely. That's what I'm saying. You listen, don't let yourself be constrained by the societal rules. They can suck it. So yeah, hundreds of matter consists of a single phase or its volume, two more phases. Makes sense, and that's actually a great way to define it. I love it. It's such a specific definition. That's always so satisfying. Triple phases. And they make it. Can be forgiven with the writing mistake. That's why I can't do my message. You can be forgiven, but at the same time, you've gotta believe in yourself, Harvey. You really have got to believe in yourself more. Don't let the haters get to you, man. Leave the comment up there. Even if they'll hate you for it, leave it up there. What are they gonna do? Tell them to suck it. You know, them. Big pineapple. Okay, that wasn't the best one of my jokes, but that's only because I'm not funny. How... Oh, there we go. The economies and the classifications often tend to break down when closely examined, and the distinction between homogeneous and heterogeneous matter is a good example. This is really a matter of degree, since at a microscopic level, all matter is made up of atoms or molecules separated by empty space. And that's why we have this. That's why we talk about matter when made out of compounds. I'm my own self like that. You have to stop that, Happy! Because that's haters getting to you, and they're turning you into a hater of yourself. Self-confidence! Believe in yourself! You're awesome! Don't be self-hating. What's the point? Where was I? This is matter of degrees and microscopic. Yes, for most practical purposes, because the matter is homogeneous when any it continues to condense too small to affect its visual appearance. That's vague, but how large amount of molecules are going to avoid such a gap between micro and macro worlds. Okay. You're becoming a hater. Into one of them. Precisely! Don't let the big pineapple... Yeah, that's the big pineapple, man! Have you ever thought about how dumb of a fruit pineapple is? Pineapple is the only fruit which actively hurts you when you eat it. It has specific molecules that are designed to hurt you. And you know why? It's because it's the haters, man. They want you to eat the pineapple, alright? They want you to hurt yourself. It's all part of a single conspiracy. You can't let them get to you, man. Don't listen to their lies. Was I reading such particles span the gap between micro and macro worlds? Now, no colloids since they began to be standard around 1900. With development now, technology in the 1990s, this can become even more fuzzy. To the air around us, most of the liquids and solids we encounter and all too much of the water we drink is not of pure substance but of mixtures. To have a general idea of what the mixture is, how it differs per substance, what is the scientific frame for making it? Yeah, precisely. I really love these exact definitions because, like, before this book, we could sit here and debate whenever something is like a mixture, pure substance, heterogeneous or homogeneous, but with these precise definitions, we can just tell. We can just check with the definition, and I really like that. To a chemist, a pure substance usually refers to a sample of matter that has distinct, does not district make it, get it together. So, pure substance, set of properties. Distinct set of properties that are common to all this, that are common for all the samples. Alright. A good example would be ordinary salt, sodium chloride. No matter what its source, from mine, evaporated from seawater or by tree, all samples of the substance, once they have been purified, possess the same unique set of properties. Makes sense, right? Okay. Mixture, in contrast, covers two or more substances, and it can exhibit a wide range of properties depending on the relative amounts of components present in the mixture. For example, you can dissolve up to 357 grams of salt in 1 liter of water at room temperature, making possible an infinite variety of salt water solutions. So, pure substance of salt is a pure substance of salt because no matter what kind of salt you have, it will always have just sodium and chlorine. But when it goes to salt water, it's a mixture because you could sometimes have more salt, you sometimes have more water. Hey, thanks, Make It, for helping me learn random science. Helps me have fun. I lost the fun playing video games and I'm losing a lot of things that were fun for me. That's sad. The fun is still there. Okay, you have to... The very important thing you have to realize is that fun in life doesn't really come from video games or all of those things which are fun. Fun is just there, and we use those things to get this fun. Which means that even though you might be losing some things which were fun for you, which isn't fun, you have to realize this fun is still there to be had. So, I'm trying to find a good analogy. So you can still have fun. That's the point. And you just can't... You have to keep trying. Because you will have fun. Humans aren't made to not have fun. We are made to have fun. This habit texting has gotten me to look into some of the course I'm going through. Let the rabbit hole begin. It's addictive and addicting and lovely and amazing and grand, and I love LiveText so much. Thanks, but I guess that's what I'm being sad. You have to stop with that character arc. You have to bring back Happy. Make Sadie happy again. I'm gonna sell all the red hats. For example, you can solve up to... Yeah. Concentration properties, density, boiling point, pressure will be different. So mixture could just be different. So pure substance there and mixture. Multiple pure substances, which may vary depending on the ratios. Peanut butter would never willingly purchase brine advertised as impure, but the Consumer Reports article published some years ago, they were listing a number of mouse droppings and insect parts they found in the major brands. Bon appetit! What a lovely fuck to drop right in the middle of the... Great! Yeah, okay. Okay, insect parts aren't that bad. Okay, insect parts I can tolerate. Right? I can tolerate that. That's... For some reason, I'm not really disgusted by the insects, but mouse droppings though, because that's, you know, that's not really meant to be eaten. Well, I guess insects aren't made to be eaten either, but like, you know. Why does mine just give it a plus? We have to snub. Okay, finally, we all prefer to drink pure water, but we don't usually concern ourselves with the dissolved atmospheric gases and such ions. And ions such as calcium and... looks like an acid, I don't know, I'm not good with chemistry. Which is great, I'm so glad I'm doing a chemical research last year. They are present in most drinking waters, but these harmless impurities are always present in those pure spring waters and pure water respectively. Bottom line, to a chemist, the term pure has meaning only in the context of particular application or process. Pure can only be relative to something. Makes sense. Or rather, things are pure and then they are only impure in relative to the things which we set as pure as a reference. Perfect explanation. Alright, operational and conceptual classification. Since chemistry is an experimental science, we need a set of experimental criteria for placing a given sample of matter in one of these categories. There is no single experiment that will always succeed in basically deciding what kind of question. So like a scale of purity, precisely. And also pure is just... Pure is a social construct, so it's not real, like money. If someone wants you to pay taxes, just remind them that money isn't real. It works out great every time. Why is everything a social construct? Because of society, man. Society. What isn't a social construct? Donating to charity at https://. That's not a social construct. Is time also a social construct? There is some joke to be made there, but I'm tired, so I'm just gonna say no, it's not. Alright. Operational and conceptual classifications. There's one principle that will always work in theory, if not in practice. This is based on the fact that various components of a mixture can, in principle, always be separated into pure substances. It's not? Yeah, it's not. Why would time be a social construct? The social construct is like a thing which only exists in a society. So if you destroy the society, if something still exists, that means it's not a social construct. Units of time are a social construct. I would argue that they aren't. I would argue they are just like a standard. And I don't think standards are a social construct. I think the application of standards could be a social construct, but I don't think standards are a social construct. So for example, okay, so this is the difference, right? When you have money, as in coins, right? This is not a social construct because coins are a physical thing. But when you have the value of money, so like for example, money in your bank account, that is a social construct. Because in reality, you don't really have that money. These are just some random electricity floating around. Well, not random, I guess. How can you imagine? It'd be fun. I think gravity is not a social construct, but math is a social construct. Math isn't a social construct either. Because math very much exists without society. I just can't exist without society. Oh, I get it. So your mom is a social construct. Precisely! My parents' divorce was a social construct. Alright. Hydrogen is a mixture of salt water and sand. Applying math. Yes, applying math would be a social construct. I think. Wait, can processes be a social construct? Or just things? That's a good question. If application of math... No, wait. Application of math could also be a physical thing. You know, the rabbit hole. Doesn't matter. We're doing chemistry. Consider hydrogen mixture of salt, water, and sand. The sand can be separated from the salt water by a mechanical process of filtration. Similarly, the bad fat contained milk may be separated from the water by a process known as churning, in which mechanical agitation forces the bad fat droplets colors. I'm not gonna read that again, because I have a living soon and I already read that perfectly. General principle of hydrogen may be separated from hydrogen matter by mechanical means. Okay, that's fair, but like, what is a mechanical mean then? We have an operational definition of hydrogen matter. It's a mechanical operation. Oh, I see. Like physical means equals mechanical means. Yeah, but how deep does it go? Because like, would heating up the water to just... when you have salt water, right? If you heat it up, if you boil it, and then distill it into just water and salt, is that a mechanical mean? Because in theory, you'd say that it's not, but in practice, when you have the molecules, then distillation is just mechanical movement of molecules. How do I separate the components of salt water? Most will be evaporate off the water, leaving the salt as solid residue. I literally just said that. Well, not literally, figuratively just said. Well, almost literally just said that. said the same thing. Literally said the thing with the same meaning. Make it. Get it together. That homogeneous mixture can be separated into pure substance by undergoing appropriate partial changes of state. That is evaporation freezing. Okay. But is that mechanical? So then this will be partial changes. The sentence in the last example of only water, not salt, which will be very difficult to do anyway. The idea is that one component mixture is preferably affected by process we are carrying out. The principle we emphasize in following examples. Makes sense. Distillation, fractional crystallization. Okay, so this is... let's do separating homogeneous mixtures. Chemistry doesn't exist. It's a social construct. Everything is just physical means. Okay, so we have distillation, fractional crystallization. Then we have some more. Liquid extraction, which I think is a common name. Now I'm feeling sick. Distillation first. What is distillation? Let's use definitions though, just guesswork. Mixture of two volatile liquids is partially boiled away. The particle vapor will be enriched in the component having lower boiling point. Boiled away, the distillate would be identical to the original liquid. That's why, for example, it's hard to distill water with alcohol. It's possible, it's just difficult because both of them are evaporating. But if, say, half the liquid is distilled, this liquid will contain a larger fraction of the more volatile component. That's why you can distill alcohol. From distillate and redistilled, it can be further enriched in the low boiling point liquid. Low boiling liquid. Okay, so... a mixture of two volatile liquids. Does it have to be liquids? Okay, I guess... Well, wait. You have salt water. Is salt a liquid in salt water? Wait, if you mix salt and water... Is it becoming a... Is salt becoming a liquid? Or is it just mixing with water? Which is a liquid. And if so, if you distill it, does it become solid again? Salt is just salt. Thank you for the insight. Chemistry doesn't exist. Social contract. I want to download library text into big PDF and put everything in one book and print it. I'm already tried. It's difficult. Okay, so so salt, if you mix it with water, then is this a mixture of liquid water and liquid salt? Or a mixture of liquid water with salt in a questionable state? Okay, the point is distillation. You know what, let me just copy the definition. Mixture of two volatile liquids partly boiled away. Alright, sick. Then we have fractional crystallization. I think salt becomes liquid. Yeah, I don't know because this is confusing stuff. Hot saturated solution containing two or more dissolved solids allowed to cool slowly. The least soluble material crystallizes at first and can be separated by filtration. Okay, so mixture of months, good. There's the crystals, so the materials having the highest melting. Okay, so it's just change of states, right? This is just water to gas, and then the one that has the lowest boiling point gets separated. In this case, it's liquid, not water by the way, liquid to gas, and in here it's liquid to solid, and the one which has the highest or lowest dissoluble, whatever, that gets turned to solid first. But this is liquid. Wait, why would this be liquid? I mean, the only change left would be solid to gas. Why is this liquid? Oh, it's which I'm an idiot. Okay. Crystallization. So you crystallize, and whichever is less liquidy gets less liquidy than the more liquidy one. Perfect definition. Liquid. That's an easy one. Mutually insoluble liquids, one containing two or more solubles, are shaken together in a solid funnel. Each salt will contribute in the liquid or soluble. We usually say the salt is in the aqueous state. Which is solid state before it dissolves in water. Okay, so once in water, it's liquid. Got it. Alright, so it is two liquids, and then two solutions are then separated by opening the bottom of more than solution. So liquids mixed, more dense liquid. Gravity magic stick. Chemistry is partly a study of transformations done while they can go. We can also assign to any substance a set of chemical properties can predict various changes of composition of the substance on the go. Chemical properties also include the conditions of temperature, etc., required to bring about the change and the amount of energy released or absorbed to changes take place. Well, I now understand why I hate chemistry. So many smart words. I mean, I don't know. I don't think chemistry has that many. I feel like programmers are the most pretentious group. I feel like when it comes to smart words, programmers absolutely take the cake for needlessly complicating everything. Second would be mathematicians. Third would be physicists. Fourth would be... Actually, I don't know, but those are my top three. Oh, damn it. You know what? I might need to go. Programmers, they actually have to write those words out a lot of times. No, they don't. I don't mean like in code. I mean when they are explaining stuff. Then they absolutely do not have to write them down. They just complicate things for absolutely no goddamn reason other than just to sound smart. I don't like this so much. I might need to go now. One thing I might need to do. Sorry about that. Short live stream. I was honestly hoping it would be a bit longer, but tomorrow we'll pick up precisely in this spot. I guess that'll be it. I came back in our spring home mixtures. Oh, yo, you came back the worst possible time. Have a good day. Alright, for now that'll be it. Thank you everyone so much for watching, and have a great day. Bye.